Hello, here's your second video for Chapter 5 dealing with extrema for MAC2233, Calculus for Business and Social Sciences. So our next example is find the extrema for the function 3x raised to the 4 minus 4x raised to the third on the interval from -1 to infinity. Okay, so remember we're going to find stationary singular endpoints. Stationary, we take the derivative, set it equal to 0, and solve. So the derivative of 3x to the 4 is 12x to the third. The derivative of minus 4x to the third would be minus 12x squared. Set it equal to 0. Remember, you need to know how to factor. So to solve 12x to the third minus 12x squared equals 0, we're going to factor out the 12x squared, which will leave us with x minus 1. We set 12x squared equal to 0, and that gives us x equals 0. We set x minus 1 equal to 0, and that gives us x equals 1. So there are two possible stationary points at 0 and 1. For singular points, we look at the derivative, 12x cubed minus 12x squared, and we try to see if there's anything that could make it undefined. So since we're not dividing by x or anything, there are no singular points. There'll be no sharp corners or anything. And then endpoints, we look at the domain. So since it's going from -1 to infinity, we would look at -1. Infinity goes forever, so that would not be part of our endpoints. Okay, so then I made a little table where we're looking for 0, 1, -1. 0 comes from stationary, 1 comes from stationary, -1 comes from endpoints. Then we plug into the original, the 3x raised to the 4 minus 4x cubed, to find the y value. So when you plug in 0 to the original, you get 0. When you plug in 1 into the original, you get -1. When you plug in -1 into the original, you get 7. So the three places we're going to look at is 0, 0, 1, -1, -1, 7. Now, when I go to graph this, the hard part could be deciding the window. Now remember, the graph begins at -1 because of the domain and goes forever. But I'm not going to put forever in my calculator. So looking at my x's, the largest x is 1. So maybe I'll go to like 4. See a little bit beyond that. And then the y value for the range, the lowest is -1 and the highest is 7. So I'll go a little bit before, like -2, and I'll go up to 10. So I'm going to go to my calculator. I'm going to put in, go to y equals, put in the function 3x raised to the 4, subtraction 4x raised to the 3. I go to window, and like we discussed, we're going to go from negative, make sure it's -1 for the x minimum, 4 for the x max, counting by ones, y minimum -2, y max 10, and when I hit graph, you can see that it starts at -1, it goes down, it plateaus at 0, 0, then goes down, and then goes up forever. Okay? And then we're going to look at these points 0, 0, 1, -1, and -1, 7 to see what happens there. Now, we could just look at the graph and find where 0, 0 is, and notice to the left is higher, to the right is lower, therefore it's neither a max or a min. So remember, these are possible extrema, but doesn't mean they have to be. Another way we can do is hit second trace, plug in 1 for value, type in 0, enter, and it will put right on the graph. I can do that also for 1. So second trace, number 1 for value, type in the value 1, enter, and that would be here, 1, -1. Now again, to the left is higher, to the right is higher, so that'd be a minimum, and it's the lowest min in the entire graph that there'll ever be, so that's an absolute min. And then we type in the last value, which is -1. So second trace, number 1 for value, type in -1. And there's that -1, 7. There's nothing to the left, but to the right is lower, therefore it's a max. But it's not the highest because the graph goes up forever, so that would be a relative max. Okay, let's try another one. Well, actually, let's do an application. So in 5.2, we're going to do an application with what we just learned. So weekly revenue for the latest bestseller, A River Burns Through It, at OhaganBooks.com is given by revenue equals -p cubed plus 33p squared plus 9p, p being the price, r being the revenue. And your price has to be between 18 and 28. That's your domain. It's the number of copies sold per week when the price is $P. What price should the company charge to obtain the largest revenue, and what is the largest revenue? Okay, so again, we're trying to find the largest revenue. There's your clue that we're trying to find extrema. So we're going to do stationary singular endpoints. So we take the derivative. The derivative of negative p cubed plus 33p squared plus 9p would be negative 3p squared plus 66p plus 9 equals 0. Okay? Now, unfortunately, this doesn't factor nicely, so you'd have to do a quadratic formula where a is negative 3, b is 66, and c is 9. And some of you may have the quadratic formula in your calculator, or you'd have to do it by hand. But if you did the quadratic formula, you would get you'd get 2214 as a possible answer, an answer that falls in the domain. So that would be your stationary. It's the only one of the answers that falls in the domain. And for endpoints, we have 18 and 28. There's nothing dividing by p, so there are no singular points. So the 3 points we would look at are 18 endpoint, 28 endpoint, and 2214, which we got from doing the quadratic formula. To find the y value, remember you plug into the original. So I can do that in the calculator. So if I go to y equals, clear what I had in there, and I'm going to type in the original. So the original is here. So I'm going to type in negative x raised to the third plus 33x squared plus 9x. Okay, and then if you want to use the table feature, remember you hit second window for table set. Make sure that the independent is ask and the dependent is auto. Go to the second graph for the table, and we can plug in 18 into the original function, which gives us 5022. We can plug in 28, which gives us 4172, and we can plug in 2214, which gives us 5,522 and 60 cents. Keeping in mind we're trying to maximize revenue, so the price that gives us the highest revenue is charging 2214. Now, we can also look at this by graphing it. So remember, when I go to window, we're graphing the original. The domain, x minimum is 18, x maximum is 28. Maybe we'll count by 2's for the scale. Y is revenue, so we can put the lowest to 0. And looking at the dollar amounts, 5,522.60 is the highest, so maybe go up to 6,000. And maybe count by thousands for the Y scale. When I hit graph, you can see that the revenue goes up, but then the revenue goes down. So we're trying to find the highest. So if I hit second trace, number 1 for value, 2214 is what we think the answer is. When I hit enter, it actually goes to the highest point and shows us that the most amount is 5,522.61. Another way to check it is if you hit second trace, we're looking for maximum, number 4. Go to the left of the highest point, press enter, go to the right of the highest point, push enter, guess where you think the point is, push enter, and it will give you 2214 as well. Okay, so it's nice ways to check using your calculator. Then we have this other example, not a major example, but I do want to go over it real quick. If we're trying to maximize area, remember area is x times y. So Slim wants to build a rectangular enclosure for his pet rabbit Killer against the side of his house. He has 100 feet of fence, and we know that area equals x times y. So he's trying to maximize area, x times y, knowing he has 100 feet of fence. Well, how do I do that? Well, we have a little bit of an issue because to maximize area, which is x times y, we have 2 variables there. So we have to kind of think about what we're given. Well, we know if we drew a picture, we have a house, we're building the fence along the house, and it's only going to have 3 sides. So I'll label the further side x, and then the 2 sides that are parallel from each other, they're the same, so I'll call them y. We have a rectangle. So this can actually give us another equation, because in order to solve for 2 variables, we need 2 equations. So these 3 sides, y plus x, also 2y plus x, same thing, equals that 100 feet of fence. Okay, so we need this 2y plus x equals 100 to plug into what we're maximizing. So I'm going to plug in for one of the variables. You can do x or y, and x is probably easier to get by itself. So I subtract 2y, x equals 100 minus 2y. Now, why am I doing this? I'm going to take x equals 100 minus 2y, plug in for x. So instead of x, I put 100 minus 2y. So I have y times 100 minus 2y. So now I'm only dealing with y, not dealing with x and y. And so this is the function I'm going to simplify. So y times 100 is 100y. Y times 2y is 2y squared. So now I can work with this because we're not dealing with two variables, x and y. We're only dealing with one, y. So area equals 100y minus 2y squared. So we're going to go through stationary singular endpoints. So the derivative of 100y minus 2y squared is 100 minus 4y. Set that equal to 0. Add 4y to both sides. 100 equals 4y. Divide by 4, y equals 25. That's one possible point. The endpoints, remember, we only have 100 feet of fence, so I can look at 0 and 100. But to be honest, they don't make much sense because we're not going to have one side of 0 because the rabbit would run away, or one side of 100. So you can think of it like 99 or 1, but really this is not going to give us an answer. It doesn't make sense to maximize. And singular, looking at the derivative, 100 minus 4y, there's no dividing by y, there's no singular points. So really 25 is going to be our answer. That's the one that works. You can try plugging in 0 and 100 or 1 and 99, but it will not give you the maxed area. So if we know that y is 25, if I plug 25 into that x equals 100 minus 2y or 2y plus x equals 100, you can figure out what x is. So 100 minus 2 times 25 is 100 minus 50, which is 50. So now I know that x is 50. I know that y is 25. So the max area I can get with 100 feet of fence only having 3 walls would be 25 times 50. 25 feet times 50 feet would be 1,250 feet squared. Again, this isn't a major problem, but it does kind of give you an example when we can maximize area. Okay, we're going to do one more example here. Maybe we'll save these two for the next video. Thank you.